Hello guys, myself Balkrishna Pujari. Today we are learning how to solve the thermal temperature distribution uh, in a single wall using Ansys APDL. So here is the statement for the rectangular cross section of a element 2 into 2 meter of cross section and the length of the element is 5 meter. Thermal conductivity is 60.5 watt per meter degree C, applying on a constant temperature of 150 degree C to the left side of the block and constant temperature of 450 to the right side of the block. So we have to calculate the temperature distribution. For that we have to go for the preference, then thermal analysis, preprocessor, element, add element. In that we have to consider the solid 4 node 55 element, and in the option we have to consider the thickness. Okay, so the element length is 5 meter, so that you have to add in the thickness. Now go for the material model. Now we have to consider the thermal conductivity, isotropic. We have to add the thermal conductivity here. Thermal conductivity is 60.5. That value you have to add in the isotropic, the kxx value. And okay. Now go for the modeling, create area. So rectangle by dimension 0 and 2, 0 and 2, 2 into 2 as a cross section, what we have saw in the statement. Okay, before going to the another step, we have to add the thickness. For that, in the real constant we have the thickness as a 5. That what we forgot to add in that. Okay, now go for the meshing. In that mesh, the mesh tool, and set the area as a small size, and now go for select to area and mesh. So mesh will be complete. Now go for the load and defined, apply thermal. In that we have to add the temperature on line, so consider the left one and okay. So we have to add the temperature here. The initial temperature is 150. Check in the statement, apply the constant temperature of 150 to the left side of the block. So that 150 have to consider in the left and right is 450. So 150, okay, and again consider the right one as a temperature as 450. Okay, now all boundary condition has set it. Go for the solution, solve current ls. Okay, solution is done. Now go for the general post processor, plot result. So result summary, in that result summary first one value has checked. Now go for the plot control, counter plot, nodal solution and nodal temperature. Okay, now select the size and shape and check the isometric view. Here the total thickness of that plate or that wall and the temperature distribution. Now go for the thermal flex values, temperature gradient. This is the maximum temperature gradient. So the initial is 150 and final is 450. So likewise it will be, the temperature is moving. If you want to see the animation, in the animation it will not look properly, but somewhat you will see the flow of the temperature. Okay, this is about the temperature distribution using thermal analysis on a single wall. Okay, thank you.